Hey, this is the Energy Review, problem number 18. A Honda FCX Clarity has 36 liters of hydrogen at a pressure of 5,000 psi. This is real data, and I've already converted to atmospheres. It's at room temperature, 25 degrees Celsius. That entire tank full of fuel is consumed while it's driving, and all of that steam, after all, it's forming water, gas, that exits the tailpipe at 120 degrees Celsius is cooled to room temperature and you drink it. Problem 18 states, if the fuel economy is 70 miles per kilogram of hydrogen consumed, how far did you go? Well, clearly you need to know how many kilograms of hydrogen you have, and it doesn't give you that. It instead gives you the volume of hydrogen, but it also gives you the pressure and the temperature at which the hydrogen is in that tank. So you should recall that that means we need to use the ideal gas law to figure out the moles of hydrogen. From there we can get grams of hydrogen and kilograms of hydrogen. So let's proceed. PV equals nRT, therefore N equals PV over RT. The pressure we did have to convert into atmospheres. You'll recall that this formula requires liters, atmosphere, mole, and Kelvin. So there's your pressure in atmospheres. The volume is given in liters. There's the ideal gas constant, which is R. And there's the temperature converted to Kelvin by adding 273. This works out to be 500 moles of hydrogen. Now, you can do the rest by logic. Since uh, 2 grams of hydrogen is a mole of molecular hydrogen, you've got 1,000 grams. Hey, you've got a kilogram. And you get 70 miles for every kilogram. Clearly, you're going to go 70 miles. The problem is complete. I should point out there's a couple important typos. It says need kilogram of H2O. Cross out that O. You need the kilograms of hydrogen. Cross out that O. We're just doing we're not calculating this based on water. We're calculating based on hydrogen. All of this data at the end is for another problem. Mathematically, it works out this way. 500 moles of hydrogen, where every 2 grams of hydrogen is a mole of hydrogen, means you have 1,000 grams of hydrogen. Since 1,000 grams of hydrogen is a kilogram of hydrogen, small typo there, that means you have a kilogram of hydrogen. You're at 1 it so far. And since you get 70 miles per kilogram, you're going to go 70 miles with that full tank of hydrogen. Notice all the units cancel. Moles of hydrogen, grams of hydrogen, grams of kilograms of hydrogen, and you get 70 miles. This is the Energy Review, problem number 18.